Hi guys, hope you all are doing good. So in the previous video we have learned how to create a double linked list. So in this today's lecture we will learn one of the most important operations, that is traversal. Traversal in double linked list. So don't worry, it's actually very easy. I will explain everything step by step in a easy way. So without any delay, let's begin our today's lecture. So you all know about double linked list. So the double linked list looks like, so let me write an example of double linked list. So first double linked list is gonna start with null. So it's gonna direct backward. So 10, again backward and forward direction. 20, again same forward and backward. 30 forward, this is 30 is the last node for that, that's why 30 forward null. So this is our original linked list. So our goal is to print every value in this linked list. So the special feature of the double linked list is that we can move in two directions. As I mentioned in the previous video, we can move in both directions, forward and backward. So this is the main advantage with double linked list. So first, let us understand the forward traversal. So in the forward traversal, we are going to start from the first node, and we are going to, first node means it's gonna be head node. So we are starting from the head node. So then we move using the next pointer. So for that we are going to create a temporary pointer. So we are creating using struct node. So we are creating struct node start temp. We are creating a temporary pointer. So in this, so we have successfully created the temporary pointer. So after that we are going to declare temporary pointer as temp equal to head. So temp equal to head. So this is a temporary pointer. So now the temporary points to the first node actually. So now we need a loop. We need a loop actually to print all these values in a double linked list. So same in the, has been seen in the single linked list, we use same while loop in the double linked list also. So let me write. So you're gonna write with me. So we are going to write the while loop while temp. So while temp is not equal to null, we are writing printf. We are writing a printf function percentile d. We are writing temp of data. That means we are printing the temp of data. So after that, temp will be updated. So temp equal to temp of temp of next. Yes, correct. Temp of next. So this is the while loop. We're going to print the all double linked list values in the, double linked list values in the double linked list actually. So we, first the initially temp starts from the head value, and it gonna print the temp data, and it gonna increment, it gonna move forward temp equal to temp of next until temp is not equal to null. So this gonna repeat until temp becomes null. So this is actually, so first temp starts from null, so sorry, temp starts from 10. So it gonna points 10, and it gonna print 10, and next it gonna move to the 20. So it gonna print 20, and it moves to the 30. So it gonna print 30, and it gonna move to null. The loop will be stopped. The output will be 10, 20, 30. So this is the output. So this is called the forward direction. So let us understand the backward directions. So in the single linked list we can't move backward because the point always forward. So it is only unidirectional. In the double linked list, as I mentioned earlier, we can move forward and backward. So now let us see the for backward direction. So can we directly move backward from head? No, not actually. So backward means we need to start from the, where we need to start. Yes, we need to start from the last node of the double linked list, because head points us to the first node. So first we must reach the last node first. For that we need to write initially temp equal to head. Temp equal to head. For we need, let me highlight with. So let me write here for backward. Backward traversal. This is backward traversal. So for backward traversal, initial temp equal to head. For that we need to write while, first we need to move temp equal to last node. For that we need to write temp next is not equal to null. So we need to write this condition. So temp of next is not equal to null. We need to move temp. So temp becomes temp of, yes, temp of next. You are correct. So temp of next. So now temp points to the last node. So in this example, last node is 30. So it gonna points to the 30. So now we are going to use another while loop. So we are going, this while loop is for printing. So this while loop is to reach the last node. So we are writing the while loop to print the elements and to print the nodes from the backward. So we are writing while loop. So in this while we are going to write temp is, temp is not equal to null. So let me write it again. So temp is not equal to null. So temp is not equal to null. We are going to print the value. So printf percentile d. We are going to write temp data. We are printing temp data. So in the forward direction, we have written temp equal to temp of next. But in the backward direction, we write temp equal to temp of. Can you guess it? Yes, you have guessed it correct. We are going to write previous. So in the backward direction, we are going to write temp equal to temp of previous. This time, instead of moving the next node, we are moving previous node. So let us write on it. So first temp start temp equal to head. So let me write, this is a actual linked list. So temp is initially head. So this is a temp first node. So it's gonna move to the last node. So initially, so now temp points to the 30. So temp starts from the 30. So it's gonna print 30 and it gonna move backward. So it's gonna move 20. So it prints 20 and move to the 10. So it's gonna print 10. So move to the null, loop will be stopped, the output will be 30, 20 and 10. So this is the backward traversal. So this is all about the traversal in a double linked list. So let me write in the C code. So I have already written the C code. Let me explain it line by line. So these two header files are non-negotiable. So we should write these two header files. So I declare struct node into data, next and previous. In the main function, we have declared three nodes and we have allocated dynamic memory here, as you all know. And we have given some value here, 10, 20 and 30. So this is up to here, everybody clear. This is what we have learned in created linked list in the previous video. Now here, we are creating a temporary pointer. Initial temp equal to head. Now we are printing the forward traversal. So this is all the forward traversal. First we need to write a temp is not equal to null, percentile d, temp of data. We are going to print that temp data and temp should be moved forward. So temp equal to temp of next. So this is all about the forward traversal. So we are done with the forward traversal. Now we are moving to the backward traversal actually. So let me write. So first we need to, for the forward, for the backward traversal, initial temp equal to head. So we need to move the temp variable to the, temp node to the last node. For that, we need to write this while loop. So this while loop is to move temp to the last node. So while temp of next is not equal to null. So temp equal to temp of next. So now temp is at last node. So now we are going to print the backward traversal. Initial same. While temp is not equal to null, we are going to print a percentage temp of data. So here comes temp is equal to temp of previous. We are moving the backward direction. So return 0. So this will be the output. In the forward direction, it will be 10, 20, 30. I have written here because there is no space here. So please adjust. So backward traversal 30, 20, 10. So this is all about the traversal in double linked list, forward and backward. So let me ask you some questions. Why is the traversal, why is backward traversal possible in a double linked list? So because every node stores the address of the previous node using the previous pointer. That's the thing. So why do we first move the last node? So actually, why do we first move the to the last node? Because backward traversal starts from the last node. That's why. So when we are moving from the backward, it's not possible to move backward from the starting node. So backward comes we need to know the last node of the double linked list. So that's why in backward traversal, last node should be the starting point. So that's, so can backward traversal be done in a single linked list? Can you guess it? No. In a single linked list has only next pointer. It does not have a previous pointer. If it has a previous pointer, means it's gonna call it double linked list, so not single linked list. So in single linked list, backward direction is not possible. So let us revise quickly. So let me revise quickly. uh, so this is a, so in this lecture we are discussed traversal in a double linked list. So we are discussed forward traversal. So in forward traversal, it's gonna start from the head. We are moving using next variable, next node. So we are going to stop at null. In the backward traversal, we are going to first reach the last node, and we are going to move to using previous and stop at the null value. So we have successfully completed this lecture. We have covered traversal in a double linked list in both forward and backward directions. So this is one of the biggest advantage of double linked list or a single linked list. So this is the main advantage with double linked list. So in the next video, we will learn insertion at insertion at the beginning a double linked list with easy C code. So pointer updates and on a easy diagram. So thanks for watching. Don't forget to like the video and don't forget to subscribe to our channel. So thanks for watching. I hope this lecture is clear to everyone. If you have any doubts, you can ask in the comment section. So see you guys in the next lecture.